Welcome to my talk on how to become successfully a data scientist. Before we start, some things, please. I have a little survey that we can look at the end of the talk at the results of. It's one question. So you can scan it, you can type it. Scanning is easier with your phone. Then the question that I have for the room is, who here is already like a data scientist? Some people. Who here is like working with data scientists? Okay. And so I'm just like kind of interested about the numbers that I will have in my survey. And then the last one is, who here is like an aspiring data scientist? So I'm talk for you. Okay, cool. So okay, good. Before we start, so I hope I'm gonna have like the QR code for the survey still on the next slide. So please help wanted, contribute. So yeah, so what is a data scientist? Yeah, so the term was officially coined in 2008 by DJ Patel and Jeff Hammerback, who were at LinkedIn and Facebook, and they wanted to have a job title for themselves. And they didn't want it to be too Wall Street-like, which was like the data analyst back then. And they also didn't want it to be too academic, which would have been researcher. So they found something in between. They used data scientist. And their idea was that the title sounds sophisticated and vague enough to transcend industries and be taken seriously. And then even by people who don't have any idea what it is. I think this definition has come across over the years. A lot of people still don't know what data science is. And they think it's going to do other things than it should be doing. And this definition has been, though, very helpful for the people that were in position to kind of leverage this definition. So whoever in 2008, 2010 was already like educated in data and had already like some kind of career, this definition really helped. So this is basically what happened to me back then. I had just finished my PhD. I was actually in the middle of my PhD in information retrieval, which was like, you know, it would be called data science today. And then being one of the few people who could like make use of this definition, I could already get a job in data science back then in 2011 when I finished. So for me, this was really helpful back then, but I don't feel this is really helpful today, because what it has been leading to is this feeling that becoming a data scientist means that you really have to become a unicorn. Who here has ever wanted to be a unicorn? Yeah, so you all had those T-shirts, right? Be a unicorn, be amazing. You know, we know them. So, but it's really like not really helpful if you want to get started. It feels like you got to be like start from very low to be like a rocket scientist in 2 weeks. Okay, so there's another definition of data science that is a little bit older, and this is from 1974. Peter Naur, he defined it. He talked about it, saying that the usefulness of data and data processes derives from their application in building and handling models of reality. So here is not about the hype, here is about utility, right? So let's take that a little bit, and through this talk, we are going to talk about how like to get a little bit away of the from the hype and to think about what can we do when we are learning, to think about like what is the utility of this job, what value can I bring? Where should I invest my time? Because our time is limited, so we don't have, you know, 2 lifetimes. The lifetimes, unless we're a vampire. Anybody here a vampire? No vampires. Okay, good. Not yet. Good. There's still time. So yeah. So my take on successfully becoming a data scientist is like, don't try to be a unicorn, even though the T-shirts really try to convince you to become one. Don't. Yeah. And so yeah, so let's see a little bit what has this unicorn mentality around data science led to? So I am a data science coach at Neufische. I do see, I think, a student in the room, a former student. Yeah, so data science coach at Neufische. We teach, I've been working there for like 3 years, teaching people in data science boot camps how to change their careers to data science. And so these are like some misconceptions that I've seen like from some of the students and also non-students, people in real life at work in companies. So some people think that you need to be a theoretical expert. Who has thought that about themselves when they kind of like were doing data science or thinking about data science? Anybody? So that is still something that is happening when you apply for jobs in data science, that sadly, most of the job interviews will ask you a lot of theoretical questions, whether you still need algorithms every day. Like as a software developer, when you apply for a software developer job and you have algorithmic interviews in the job interview, it feels a little bit off because then you go to work and you just write APIs sometimes, right? So where are all those algorithms that we prepared for? So that's the same for data science. Sometimes you need simple models day in, day out, and you don't need to know all the models at job interview time. But so yeah, so the industry needs to catch up on that a little bit, right? And then most of the time, what is more useful on the job is having this conceptual understanding of a lot of the models and deeper understanding of the few that you actually need, and having a little bit of a generalist mindset, especially when you're at the beginning of your career, right? I mean, at some point when you're a senior, you should specialize on some things, but beginning, not necessarily. Another thing that people think is that you need to be a programming expert. Like, honestly, with the speed of the tooling out there in AI, it's like literally like impossible to become a programming expert at everything that is currently right out there. So focus on the basic, and remember that usually if you learn at least one programming language a little bit from scratch, you can easily do knowledge transfer to another stack, right? I usually like to say like, sure, I have an experience in AWS and I'm really sure that I can really pull it off in Google Cloud or another cloud. You know, it's like same shit, different cloud. But don't quote me on this. Anyway, so but you do need to kind of have this a little bit of build up this confidence, like, which is usually evidence driven. So you've done it a couple of times, transfer knowledge from one thing that you learn to another so that you can talk about that in job interviews. Yeah, I don't know that now, but I did PyTorch, so I'm pretty sure that I can do TensorFlow if you ask me, right? I mean, it's not that difficult to change, right? So another thing that people need, and this is the unicorn in the room, you need to be a unicorn, excellent at programming, statistics, linear algebra, databases, SQL, visualizations, and know a lot about industry, all the industry, of course. I mean, not just one, right? All of it. So yeah, not really. Getting started, right? You really need to be good at one or two things, but you need to know you need to care about all the other things. You can't just like say, I am good at statistics and I think programming is not important. That is not really going to be a good teamwork that you're going to have as an experience. So data science is a team. You probably heard this before. Data science is like a team sport, and you need stuff gets done in a team most of the time, and you need to learn from other people. Yeah, and then you can seem mediocre, as I said before, in a job interview. Yeah, you don't know everything, and you shouldn't be expected to know everything, but you should have good communication skills and show via examples that you did manage to work effectively in a team or deal with new problems. And you can always practice this by finding group work projects that you can do. Contribute to open source, right? Yeah. So another thing people think is that you need 100 models to produce a useful solution. Especially people learning is like, you know, it's like, I mean, honestly, this kind of work, in my opinion, is the one that will be replaced by AutoML, or is already replaced by AutoML, and also LLM-based solutions, right? So don't be that person that can be replaced. Don't put yourself in that position. So practice more, rather being like working iteratively and interpreting those results that you get at every step, and go into the next step with like an informed decision and not just try everything because something's got to give. Yeah. And ask yourself a lot of questions. Why is this happening? Why is this working the way I expected it? Why is it not working the way I expected it? Okay, another thing that's happening quite often, and it also happens in job interviews, is you need to show all the things you know. Who's here has been in a job interview and was asked a question, and instead of answering for 5 minutes, they took half an hour to answer because they covered everything. So you hardly ever need to show that you know everything, or you hardly ever need to show all that you know. You usually need to show that you can solve a problem in one way and that you can create a useful baseline. And then if you have to improve it, you have an iterative approach to improve that. What would you do next? And then again, next. Not, you don't need to make a 1-year plan for a machine learning model, right? You need to make smaller steps. And then think about that in a job interview, you have actually a limited time to make an impression. And it is better if you ask the person back what is important for them for you to focus in the follow-up answer. Do they care about time, about speed, the impact, the tech depth, and everything, and then answer based on what is valuable to them. And that makes you seem like a future employee in general that cares about the value that they produce, and that comes across as a very good skill anyway, which everybody should practice. Yeah, so how do we do this? Getting started, right? So the thing about data science is that it's kind of as a profession, is going a little bit through a refinement process, right? It was like vague, and everybody was just hiring data scientists because it was popular, and now we are kind of going to, do we really need data scientists? Do we have budget for this? We actually need to do dashboards. Maybe we get a data analytics engineer, and what do we need, right? So companies are starting to ask themselves, what do they need? And then the role is going to start being a little bit better defined itself. So let's look at what is the foundation that I think should be there in order to build, a house. Anybody here has built a house? Nice. So a couple of people know that you can't start with the roof, right? I mean, can you? So depends. Okay, so depends on us. Sometimes apparently you can start with the. I've never built a house, and I don't think I will. But so statistics. So about data, you should really know your statistics and your probabilities, and like understand distributions and understand how to read other people's insights, how to learn from others, how to develop both your analytic and your business domain knowledge, and like how do you combine those. And because you always start with like, you get the data, you clean the data, you do EDA, you do feature engineering, and the more you understand your data and the business, the better you will get at doing those things, right? And what's coming up now more is that in most online businesses, A/B testing gets done and online experimentation gets done. So, and for that you need statistics. Like, I mean, just a little bit to understand what happened there. For machine learning, again, basics are essential. There is no point in really understanding in depth how large language models work as a data scientist if you don't understand how linear regression works. I don't even know, is it even possible to understand it the other way around? But so really try to understand the basic models. Most of the decision making in industry is still done on tabular data, spreadsheets and databases. And decision-making problems need to be accurate, the models need to be efficient and interpretable. Because it's a decision. You want to, I mean, GDPR even says, like, if the decision was done based on my data, you need to tell me why it was done like that. So nobody will want a black box for their decision. So if you're working in like a standard, if you're planning on working in like a standard business in Germany, which is like, I don't know, finance or something, you probably need to be able to interpret your models. So another thing that is important, of course, you start with Python. You can also do R or Julia or whatever, but you need to, your skills for programming should go a little bit beyond the Jupyter notebook or whatever notebook you're using, because data science is a little bit transitioning also towards more software engineering skills are needed, and that includes code testing, code review, you want to work in a team, you want to exchange information with your colleagues about your work, you want to keep track of it. And of course, you need effective pandas, NumPy, SciPy, Matplotlib, and other data visualization. Effective, that means that you can like start being fast at writing code. Yeah, so there's that. But the final part, the glue about everything, because in the end, you're working in a team and you're working in a company and so on, is communication. Data as a, what is data? It's a thing. I was like, it's a cross-functional thing, right, in a company. The data science team does not work alone on data science projects. Data analytics doesn't work alone. They have to interact with stakeholders, with other teams. And in a company where so most of the companies in Germany, since like they're trying really hard, but since a lot of time they are trying to become data driven, right? Some of them are succeeding, some of them are faster, some of them are, just trying. And that data driven is like, it's a mindset that happens everywhere in the company. And for that to happen, you need basically, everybody will work with data and they want to be curious about how that works. And so you as a data scientist, you will never be like working alone and on your own, right? So you need to clearly gather requirements and scope your problem, use storytelling and visualization to demonstrate the impact of what you're working on. And you might even have to like pitch your project to get budget approved for you to work on it, so on. So how do you do it? Of course, there are at least 3 ways. You can do self-learning, short programs, long programs, like get a degree, and all of this, like whichever works for you is depending on where you are in your experience. If you just finished high school, then probably you want a degree or something practical, or you want a combination. If you already have a lot of experience, then probably self-learning works for you if it worked in the past already. So you need to find out what's, best for you, and don't let anybody give you advice, just ask for advice and then still make your own decision. So yeah. As I promised, what do successful learners have in common? So these are some of the things that we've noticed during the bootcamp. So like trying to move a little bit now from the vague and sophisticated to useful, and how is that like kind of how do people do that? So being resourceful and have strong motivation intrinsically, you have to be fine with not knowing everything all the time. Is there anybody here who knows everything? Good. So it's there's one. Okay, good. There's always someone. Yeah. But you have to be up for figuring it out, and like building up that evidence for yourself that you didn't know it once, and you figured it out, you didn't know it again, and you figured it out. And then you can always say you're confident about that. And it used to be, I don't know, how many people here wanted to be a doctor when they were growing up? Anybody? Yeah. So there's one. I also thought about it for a second, but then I thought, oh my God, this profession, you have to learn all your life, So then I got into computer science. It didn't seem like that back then, and then data science. And then it turns out that this is also one of those where you kind of have to be up for learning all the time, because the space is just changing all the time. So that's why I got a doctor title. Anyway, so yeah, prioritize effective teamwork. I said it several times. You cannot be the unicorn, but the team can be a unicorn. And you might be different parts of the unicorn. Sometimes you're the feet. Another year you're the butt. I heard that the butt is really good. The tail, the horn, whatever. So it's a team sport, right? Another good skill is to know when to stop and to be able to stop. Like, you can't investigate every data thing all the time, because you're working for a company, and their time is definitely money, and you need to deliver results, and you have to be able to say, okay, this is enough. I know why it doesn't work, and then I have to stop, and I am not getting discouraged about it now, right? And have good technical writing skills. There are 2 ways to achieve this. You can use large language models. So Max just presented the bot that can write for you, explain the pull requests. Try it out, yeah? Or learn how to write your documentation, code reviews. The world has changed a little bit. We are not really working so much in person all the time. And we kind of switched from a lot of meetings to more documentation desired, hopefully. some places more than others. And I had a colleague who was always writing a lot of documentation because he was always saying, future Kayo will not remember what past Kayo wanted to do here. So if you don't want to write documentation for others, write it for yourself. Our memory is really bad. I mean, unless some people have really good memory. Okay, so my opinion on what role do large language models play in the future of learning data science. My recommendation is you should definitely try using large language models, play around with them, try to use them day to day, and understand what they can do well and what they can't do well. And try to not invest in the skills that they can do well and invest in the skills that they can't do well. Yeah, so think about it like I have here is a little analogy, traveling. Yeah, so back in the day, you used to travel on foot. You know, when you read books, it took like 5 weeks to get from Hamburg to Frankfurt. I don't know. I'm just very old books, right? It used to be on foot, and then there were cars, and then now it's like, anyway, you can get there really fast, right? So this got efficient. One thing you still need to do is you need to say where you are going to go, right? Even though something else is going to take you there. And then you also need to you need to learn how to walk before, even today when traveling is solved, you still need to learn how to walk before you can ride a bike. Did anybody here bike before? I mean, this is Hamburg, so it could be possible that it's the other way around, that people bike before walking, but you still need to do it, even though the traveling now is like super nice and efficient. And you need to then, you ride the bike and then you learn how to drive a car. And some of us even, anybody here can fly a plane? Yeah. And most of us are perfectly fine not being able to fly a plane. Doesn't mean we can't use the plane, right? So there we go. That's that. So let's see what we admired in our peers with the survey. Let's see. Do I need to refresh? There we go. So we have, winner is visualization and storytelling. Then we have data-driven decision-making mindset and discuss their mistakes. Yeah. And the least one, bash skills. Why is nobody hyped about terminal? No. And knowing lots of machine learning models. Really not an admirable skill? Okay. And automatic feature engineering. So there we go. This was, I will insert it in the slides and I'll publish the slides later. But yeah. And that's it. That's my talk. Do you have any questions? So thank you very much. This talk, I have to say, I couldn't have done it without my colleague, Noah, who was really, she's like my organization, like when I'm messy, she's organized. So that's sometimes really helpful to have colleagues that are good at the things you're not good at. Yeah, so you can follow me on Mastodon, LinkedIn, you can reach out and so on. Do you have any questions? Oh, I was in touch.